Hello guys, hello. I want to show you how to deal with maths paper 1. Since I know you guys you are writing on Friday, I just want to prepare you for mathematics paper 1. So in this paper, November 2023 maths paper 1, I want us to go and look at functions, calculus and sequence and series. So I'm going to start with this question 4. It's question 4. The sketched below is the graph of f of x, which is equivalent to 2 to the exponent x minus 4. For x being the element of -2 up to x being 4, whereby 4 is excluded. Okay, a and b are respectively the y and the x intercept of f. The first question say write down the equation of the asymptote of f. Write down the equation of the asymptote of f. If you look at the function f is f of x equals to 2 to the exponent x minus 5. Now this function f, it is the exponential function. It is the exponential function. How do I know that is the exponential function? Because my variable x is the exponent. So 2 to the exponent x minus 4 is your function. X is the exponent, so this is the exponential function. And I know that the exponential function has got only the y asymptote. The exponential function has got only the y asymptote, and that asymptote in this case, it is this number here, this -4. It is your y asymptote. If your function, maybe let's say you had a function such as, let's say you had g of x equals to 3 to the exponent x plus 5. Your asymptote in this case, this is g of x is still the exponential function, and I said the exponential function has got only the asymptote of y. In this case, your asymptote was going to be positive 5. So if we go back and answer this question where they say write down the equation of the asymptote of f, I said this f, this exponential function, has got only one asymptote, and the asymptote of f, it's only the y asymptote. And what is the asymptote? This number here, -4. So the equation of the asymptote, it's y equals to -4. Simple, you get your 1 mark. Remember guys, the exponential function has got only one asymptote, and that is the asymptote of y. So if your function, maybe let's say you had this a function like h of x equals to 3 to the exponent x, what will be the asymptote of this function? It is still exponential, and exponential has got only one asymptote. What will be the asymptote of this function? This one, the asymptote, the y asymptote is 0. So the equation of the y asymptote was going to be y equals to 0. Why? Because there is no number here. Normally, the asymptote is the number after 3 to the exponent x. This number which comes immediately after 3 to the exponent x was going to be your asymptote. So you don't have the y asymptote. Even if your function was, maybe let's say k of x is equals to 3 to the exponent x minus 2, the asymptote here, this is still the exponential function. The asymptote is still y. The equation of the asymptote is still y equals to 0, because there is nothing here. We don't have a number. But if it was k to the exponent, if it was function of k, which is 3 to the exponent x minus 2, maybe minus 5. This -5 was going to be the asymptote of y equals to -5. So it's very important now to know that the exponential function has got only y asymptote. the exponential function, sorry, has got only the y asymptote. What's happening? Okay. Exponential function, guys, has got only the y asymptote. And finding the asymptote of exponential function, it's very simple. Finding the asymptote of the exponential function, it's very simple. But I want to explain why we are saying the y asymptote is actually this -4. We are saying the y asymptote is -4. Why are we saying the y asymptote is -4? Let's go back to our equation. Our equation is f of x equals to 2 to the exponent x minus 4, which is the same as this f of x. Remember, it represents y, which is the same as y equals to 2 to the exponent x minus 4. Now, I am saying the y asymptote is -4. I want to explain why we are saying the y asymptote is -4. Suppose you have got a table like x and y. Let's say you are asking yourself, when y is 4, what is the value of x? When y is 4, you see where there is y, I'm saying it's 4. Your question is, what is the value of x? So let's go to the equation, and where we see y, we put 4. So we're going to have, if we go to this equation where we see y, we put 4, we're going to have 4 equals to 2 to the exponent x, uh, sorry, okay, yeah, let's say y equals to 4. Okay, let's say when y equals to 4, what is the value of x? So you say, where there is y, you put 4. You say 4 equals to 2 to the exponent x minus 4. Now you keep solving, you take minus 4 to the other side. You're gonna have 8 equals to 2 to the exponent x. When you solve for x, in this case, you might want to make your base to be the same. This is an exponential equation. So you have got 2 to the exponent 3 equals to 2 to the exponent x. Therefore, x equals to 3. Meaning that when y is 4, the value of x is 3. But I want us to find the value of x when y is -4. This is going to be interesting now. I want you to pay attention. When y is -4, what is the value of x? Let's go back to the equation, which is y equals to 2 to the exponent x minus 4. So we are saying when y is -4, meaning we put y with -4, -4 equals to 2 to the exponent x minus 4. Now, if you take this -4 to the other side, you are going to have minus 4 plus 4, which is 0. 0 equals to 2 to the exponent x. And in this case, there is no solution of x. Yes, there is no number which when 2 is raised to that number, maybe 2 to the exponent any of the number, none. There is no number that exists whereby you can raise 2 to that number and get 0. So this kind of equation, we don't have a solution of x, meaning that when y is -4, there is no solution of x. That is why we say this is the y asymptote. This implies that when y is -4, there is no value of x that can satisfy the equation whereby y is -4. So that is why we say y being -4 is the y equals to -4 is the equation of the asymptote. Remember, guys, it's very easy to find the equation of the asymptote from your exponential function. Get this 1 mark. It's very easy. This 1 mark, it's very easy. Now, suppose, guys, I'm trying to answer this question paper at the same time teaching you ideas of function. I'm not only focusing on answering this paper, getting the correct answers. I'm also focusing on giving you ideas of how to deal with functions on Friday. Remember, you are going to write, you are writing mathematics paper 1. Those who are writing June, this Friday, you'll be taking your maths. So I want us to go through these functions. My focus is not only on you being able to answer this question paper only. I want to prepare you for maths paper 1. I want us to be able to deal with functions. So let's say, suppose we were asked to sketch this graph. Suppose the examiner just give us this f of x. He says f of x equals to 2 to the exponent x minus 4. Suppose we are asked to sketch this function f of x. How can we sketch this f of x? Okay, remember that this is the exponential function. You see that x is the exponents, is the exponential function. So the first thing that I want you to go for is the asymptote. Exponential function has got only y asymptote, and we said this is your y asymptote. So the equation of the asymptote is y equals to negative 4. So what you do, you go straight to your Cartesian plane right away. Minus 1, minus 2, minus 3, minus 4. At minus 4, you put a dotted line, because when y is minus 4, there is no value of x. So this is your asymptote. You show the asymptote with a dotted line. This is the x-axis. This is the y-axis. So you show your asymptote on a Cartesian plane with a dotted line. Very simple. You are sketching the graph. It's very important to show us the asymptote. In this case, your asymptote is negative 4, and it's the y asymptote. That is why you go to the line of y at negative 4, you put a dotted line. Let's say we have minus, here is the x-axis. It's wrong to put the dotted line here. Oops. It is wrong to put the dotted line here. When x is minus 4, don't try and come and put the dotted line here. Remember, we are talking about the y asymptote, not the x asymptote. So don't put your dotted line on the x value. Put it on the y value, negative 4. Okay, this is wrong. Don't do this. So you show us the asymptote, and it's very important again, guys, to know that this y asymptote is the horizontal asymptote. So if we say to you the horizontal asymptote, you need to know that we are talking about the y asymptote. So let's continue. We are sketching the graph. I said to you, when you sketch the graph, it's important to show us the asymptote. Now, what you do, you use the table method. You use the table method. You ask yourself, you do this, you say x and y. You say when x is negative 2, just start at negative 2, guys. You say when x is negative 2, what is the value of y? You ask yourself, you input negative 2 on your equation. Remember, f of x is equals to 2 to the exponent x minus 4. So where there is x, you want to know y, so you say y equals to 2. Where there is x, you put negative 2. You say minus 4. You want to know the value when x is negative 2. You want to know the value of y. So you say y equals to 2 to the power negative 2 minus 4, which is the same as y equals to 1 over 4 minus 4. Y equals to, you press your calculator. I don't have a calculator here with me, so it's 1 over 4 minus, it's 4. You will press your calculator, you guys. So 16 over 4, 4, 8, 12, 16. Yes, it's minus 15 over 4. So when x is negative 2, y is minus 15 over 4. You can it's good to put it in a decimal form. It's good to put it in a decimal form. Unfortunately, I don't have a calculator with me here. So when x is minus 1, you ask yourself what is the value of y. So you go back to the same equation. You go back to the same. Let me erase this part. So you have to ask yourself, when x is minus 1, what is the value of y? So you come to this function, to this equation, you say y equals to 2. At x, you put negative 1 now. So you're going to have y equals to 1 over 2 minus 4. Just press your calculator, guys, and ask, what is this 1 over 2 minus 4, which is the same as, it means this time around is going to be minus 15. No, I need to be careful. 4, it's 8 over 2. It's minus 7 over 2. Just press your calculator. It's minus 7 over 2. Then when x is 0, y is negative 4. You say y equals to 2 to the power 0. Where there is x, we now put 0 minus 4, which is y equals to 2 to the exponent 0 minus 4 is negative 3. So y is negative 3. When x is 1, you will continue with the same process. Y is negative 2. When x is 2, y is 0. So now, because you have created this table of x and y, you can easily sketch your graph. It will be easy now to sketch your graph using the table method. You come to your table, you say, when x is negative 2 is somewhere here, negative 2. When x is negative 2, when x is negative 2, y is minus 15 over 4. What is minus 15 over 4? Minus 15 over 4, it's 4, 8, 12. I know it's negative 3 comma something. You will press your calculator. You'll press your calculator. Negative 15 over 4, 4, 8, 12 is negative 3 comma something. So I'm just going to say when x is minus 2, I match it with negative 3 comma something. You will find the correct value and you match that y value with this x value. Minus 1, you match it with minus 7 over 2, which I know that is 3 comma 5. Yes, 7 over 2 is 3 comma 5, which is between minus 3 and minus 4. So what I can do, I can put minus 2. For sure, minus 2 matches with minus 3,8, minus 3,7, somewhere closer to 4. So let me put this one here. Then minus 2 match, oh, that was, yes, then minus 1 match with minus 3,5, somewhere between negative 3 and 4. I'm trying to put the dots, they don't appear very well. And then you match, now you match 0 with minus 3, it's here. You match 1 and minus 2. Let me say my 1 is here, minus 2 will be here. You match 2 and 0, 2 and 0. So your graph will be going like this. Remember, yes, your graph will be going like this. Will touch the y-intercept at negative 3 here. Your graph is something like this, which is the same graph that you see here. This side is the graph of f. If you look at the question paper, they've drawn the graph of f. Then when x is 2, y is 0, it means we are touching this graph here. Our x-intercept is 2. Our y-intercept is negative 3. So this is how you sketch this exponential function. You just need to show us the asymptote and then use the table method. You start matching. When x is minus 2, y is minus 15 over 4. When x is minus y is minus 7 over 2. This is a table method of sketching the graph. They did not ask you. I'm just sketching it for you so that you, if they ask you in the coming exam on Friday, you can be able to do that. So I'm going to go back to the question paper and then answer their question. What was the second question? Determine the coordinates of B. So let us find the coordinates of B. If you go to your graph, if you go to the graph, you can see that B is actually the x-intercept. B is the x-intercept. And guys, you can be sure that they will ask you about the x-intercept and the y-intercept. Expect this kind of questions in the exam. You should be able to find the x-intercept of a function. In this case, we want the x-intercept of function f, which is the exponential function. So the B is the x-intercept. So I want to find the coordinates of B. Let me change the color. I don't like this color, is not that visible. I want to find the coordinates of B, whereby B is the x-intercept. So I'm going to let y to be 0. So I'm going to say my function f of x equals to 2 to the exponent x minus 4. I want to find the coordinates of B, which is the x-intercept. And to find the x-intercept, we let y be 0. So you put your f of x to be 0. 0 equals to 2 to the exponent x minus 4. Then you continue solving. You take minus 4 to the other side, becomes positive 4 equals to 2 to the exponent x. When you take minus 4 to this side, becomes positive. You are dealing with exponential equation. Make your base to be the same. If possible, you look at the base here is 2. You need to change 4 so that it has a base of 2. And then 4 is 2 to the exponent 2. So you look at this 4 as a base of 2. 2 to the exponent 2 equals to 2 to the exponent x. Therefore, x equals to 2. So the coordinates of B, guys, is 2 and 0. What is important here is that B is the x-intercept. Why do we say B is the x-intercept? Because your graph F is cutting the x-axis. The point where your graph cut your x-axis is called the x-intercept. And at that point, the value of y is 0. That was the coordinates of B, 2 marks. Now I'm going to the coordinates of A. Oh, no. They didn't ask me about the coordinates of A. Or they want the equation of K, a straight line passing through A and B in the form. After all, for me to answer 4.3, to find the equation of K, because K passed through A and B, I need to know both the coordinates of A and the coordinates of B. I need to know both the coordinates of A and the coordinates of B for me to know the equation of K, which is a straight line passing through A and B. That straight line, if you look at the graph, that straight line is not there. The straight line K passing through A and B is not there. So I will try to show you that the point A and B, at A and B, they are saying there is a straight line moving from A going to B. So this is a straight line they are talking about. Unfortunately, it's not really straight. I'm failing to create a very accurate straight line, but this is a straight line passing through A and B, and they are calling this straight line function K for sure. Let's call it K of X. You remember this one, it's F, it's function F, but the straight line passing through A and B, it's this straight line is called function K of X. So they want to know the equation of a straight line. We know the coordinates of B. Remember, the straight line is passing through A and it's also passing through B. We know the coordinates of B is 2 and 0. So we need to find the coordinates of A. For us to know the equation of a straight line, passing through A and B, we need to find the coordinates of A. You look at A, A is the y-intercept. You look at A on your graph, you will see that A is your y-intercept. Y-intercept is where is A is the y-intercept of f. A is the y-intercept of f because this is where the function f cuts the y-axis. A is the y-intercept. A is the y-intercept. Is the y-intercept of which function? Of function f of x. So to find the coordinates of A, since A is the y-intercept, we let x be 0. We are having f of x equals to 2 to the exponent x minus 4. This is your function f. Now to find the coordinates of A being the y-intercept, you let x be 0. You say f, your x becomes 0, 2 to the exponent 0 minus 4. So f into 0 becomes negative 3. So the coordinates of A is negative 3 and 0. So the straight line K, let me just create a straight line here. The straight line K passing at A, where the coordinates is negative, say, we set the coordinates of A is 0 and negative 3. You need to be careful of this kind of mistakes, guys. It is x which is 0, y is negative 3. Remember, this is the y-intercept. A is the y-intercept. To find the y-intercept, you let x be 0. So it is x which is 0. Let me erase even here. It should not be minus 3 and 0. The coordinates of A is 0 and negative 3. My apology. My apology. You need to be careful of this kind of mistake. Yes. So A is 0 and negative 3, where B is 2 and 0. So now you are looking for the equation of a straight line passing through A and B. To find the equation of a straight line, you need to find the gradient. I wish this m that I'm writing here was a small alphabet m. To find the gradient, you do change in y over change in x. You say y2 minus y1 over x2 minus x1. When you are looking for the equation of a straight line, guys, remember we are looking for the equation of a straight line passing through A and B. It's important to find the gradient. You need to find a way of finding the gradient. You need to find a way of finding the gradient. So your gradient, you're going to say, let's say this is my y2, this is my y1, this is my x2, this is my x1. So it's going to be y2, which I said it's 0, minus your y1 is negative 3, over x2 is 2, 2 minus 0. So your gradient, you press your calculator. Your gradient is 3 over 2. You can now find the equation of a straight line passing through A and B. You say y equals to mx plus c. This formula is there on your information sheet. You can say y equals to 3 over 2, your m. Remember your m, your gradient, it's 3 over 2. You now just need to find, you need to come with a strategy of finding this c here. How can you find c? Actually, I know that c is negative 3, but I want to show you how to find this c. You use any point on the line. You can use the point A. Remember that we are looking for the equation of a straight line passing through A and B. You can use any point on the line. You can use A or you can use B. Let me use B. At B, you put your y to be 0. 0 equals to 3 over 2. Your x is 2 plus c. You solve for c. Is going to be 0 equals to 3 over 2 times 2 is 3. 3 plus c. Therefore, c equals to negative 3. If you take this 3 to this side, c equals to negative 3. So the equation of this straight line it's y equals to 3 over 2x minus 3. This is the equation of a straight line. K of x, you can even call it, you say k of x equals to 3 over 2x minus 3. The equation of a straight line passing through the point A and B. Guys, we should know how to find the equation of a straight line passing through 2 points, A and B. Okay, now on 4.4, let's go to 4.4. Calculate the vertical distance between K and F. I need to, let me erase here. I want us to look at the graph. Remember, remember we have a straight line passing through A and B. I will have difficulty creating that straight line, sorry. Yes, like this. Straight line passing through A and B. So they say calculate the vertical distance. Oh, sorry. Calculate the vertical distance between K and F. This is the function K is, and the function F is here. So they want the vertical distance between K and F at x equals to 1. So let me say x equals to 1. Suppose x is 1 here. So they want to know the vertical distance between K and F whenever x is equals to 1. So what I want us to do, I want us to go to the function K and find the value of y when x is 1. Remember, the focus is they say they want the vertical distance between K and F whereby x equals to 1. So yes, you go to K, to the function K. On the function K, you substitute your x value with 1. You want to know what is the y value at K, at the function K when x is 1. Let's do it by writing. Let me erase this side because I'm writing this side on the right side. Let me erase, guys, few seconds just to erase here. And actually, I want to give a bigger picture of what is happening. I want to give you a bigger picture of what's happening. You have a straight line, which is K. You have a function F, which is something like this. I wish I drew them with different color. This is, let me try. Let me say this. Yes, I'm just messing up this straight line. It's a straight line. You still remember this straight line is K of x. And this other function, it's f of x. So they want to know the vertical distance at x equals to 1. I will just say, suppose x equals to 1. Let me create also the Cartesian plane so you can see it. Let me create the x-axis and the y-axis. Let me say you have the x-axis and you also have the y-axis. This is the x, this is the y. So suppose they want to know the vertical distance between K and F at x equals to 1. Let's say x equals to 1 at this point here. Let's say this is the x-axis. Let's say here it's 1. So they want to know at x equals to 1. Let me draw a dotted line touching x equals to 1 like this. Yes. So what they want is the vertical distance between K and F at x equals to 1. That vertical distance, let me show it with a green color. This part is your vertical distance between K. Remember this one, this function on top. This one on top is your function K. And this one underneath is your function F. So this portion, they want to know what is the distance. Let me just say this is C, this is D. So they want to know the distance from C to D, or you can say from D to C. So how you approach this problem? You go to the function K. You still remember K of x is equals to, I did find the equation of k. K of x was 3 over 2 x minus 3. So you go to this function k, you substitute x with 1. So you want to know the value of y when x is 1. 3 over 2 minus 3, which is 2 times 3 is 6. 3 minus 6 minus 3 over 2. Guys, you press your calculator. I might make some mistake here, but I know this is 3 over 2 minus, I want 2 over 6. Yes, it's minus 3 over 2. So your y value is minus 3 over 2. So yes, then you go to f. You look for f where the x value is 1. So you still remember your function f is 2 to the exponent x minus 4. So you say f into 1, 2 to the exponent 1 minus 4. Therefore, your y value is negative 2. So you have got, let me do this. I want to change the color. So the vertical distance, you at k equals to 1, you have minus 3 over 2. F into 1, you got minus 2. So you just need to subtract the two values, minus 3 over 2 and minus 2. Minus 3 over 2 is minus 1 comma 5. So you're going to subtract minus 1 comma 5, minus 3 over 2 actually. You subtract it with negative 2. You are looking for the distance. Remember, the distance cannot be negative. So what matters most is that you need to subtract these y values. Even if you swap them other way around, just know that the distance is not going to be negative. So this is the same as negative 3 over 2 plus 2. What is negative 3 over 2 plus 2? Is negative 3 over 2 plus 4 over 2, which is 0, 5. So the distance between the vertical distance between k and f is 0, 5, meaning from C to D, the distance there is 0, 5. Okay, let's go to 4.5. 4.5, they say, write down the equation of G. Write down the equation of G. Sorry. Write down the equation of G if it is given that G of x equals to the function f of x plus 4. This should be simple, guys. You are looking for the function G. Remember, G of x, they are saying G of x is equals to f of x. This is an easy mark. F of x plus 4. So we want to know the equation of G. So you say G of x equals to, you substitute f of x. You know your f of x is 2 to the exponent x minus 4 plus 4. This was easy. This 2 to the exponent x minus 4, guys, this one is your function f. It's your f of x. Where did I get the function f of x? Here it is here. This is your f of x. Therefore, your g of x becomes 2 to the exponent x. This is the answer for 4.5. G of x is 2 to the exponent x. Now they want the domain of the inverse of g. Okay, the domain of the inverse of g. When they say g to the power negative 1, they are looking for the g to the power negative 1 implies the inverse of g, not the derivative of g. You need to be careful. G to the power negative 1 is the inverse of g. So they want us to write down the domain of the inverse of g, not the domain of g. Your function g is this one. G of x equals to 2 to the exponent x, but they don't want the domain of the function g. They want the domain of the inverse of g. Okay, let me ask you, what is the domain of g? If I say find the domain of G, what will be the domain of G? The domain of G will be, I see X being the element of all real numbers. G of X equals to 2 to the power X. I'm asking, what is the domain of G? First, I'm dealing with the domain of G first. I will come back to the domain of the inverse of G. I'm saying, what is the domain of this function G? I'm starting with the original G, not the inverse. What is the domain of this function G? Okay. Another thing you can ask yourself, you can even try to sketch this graph. G of X equals to 2 to the exponent X. If you sketch the graph, this function, you will realize is in this way. G of X equals to 2 to the exponent X, it's a graph of this form. Sorry, it must not touch the x-axis. Sorry, guys. It must not touch your x-axis. So it's going to be like this. So the question is, what is the domain? The domain of this function G of X equals to 2 is X is the element of real numbers. All values of X can be found from this function G. Remember, it's continuing in this direction and it's also continuing up in this direction. So there are many values of X that we can find from this function G. So the domain of this kind of a function, G of X equals to 2 to the exponent X, it's X is the element of real numbers. What is the range? You will realize that the range, this is why I want you to pay attention now. The range, which is being the set of Y values, the range is Y is greater than 0. All the values of Y, they are above your x-axis. Look at the graph. The graph is above the x-axis. Here again, we have 0 here. So the range is Y is greater than or equals to 0. Okay, guys, I want you to understand. Suppose your function G was like this now. Suppose your function G was like this. G of X equals to 2 to the exponent X minus 1. What was going to be the range? The range was going to be Y is greater than negative 1. Because your graph was going to be like this, something like this. If you sketch this one here that I'm talking about, here you are having the asymptote at negative 1. So the graph is of this, sorry, it is not going to touch this line of negative 1. It's going to be something like this. So you see that your function is above negative 1. So the range of this kind of function, you're going to say y is above negative 1. So back to the g of x which is 2, which is g of x which is equals to 2 to the exponent x. What is the domain of this function? I said the domain x is the element of all real number, but what is its range? Y is greater than 0. That is for g. So now what will be the domain of the inverse of g? The domain of the inverse of g, you will swap, you'll go to, okay guys, listen attentively. What was the domain on the function g will become the range. So your range is going to be, what's going to be the range? Y is the element of real numbers. It's your range. And what will be the domain? The domain will be x is greater than 0. It's like they are swapping. I can find, okay, this is the inverse. I can find the domain of the inverse using the original function g. What was the range on g will now become the domain of the inverse. Oh, hopefully you are getting it. What was the domain on the function g will become the range on the inverse of a function g. What was the range on the function g will become the domain on the inverse of a function g. It's like they are swapping role. Just watch out for what's happening there. So the domain here was going to be x is greater than 0. Write down the equation of the inverse of g. It should be simple. Write down the equation of the inverse of g. To find the equation of the inverse, you just need to swap your x and your y. Simple maths. To find the equation of the inverse g, you just need, okay, let's go back to the equation of g. You just do you remember the equation of g? The equation of g is g of x is 2 to the exponent x. So to find the equation of the inverse of g, what you do, you swap x and y. Simple. Where at this position there was x, we put y. At this position was y, we put x. We just swap them. Then we make y the subject of the formula. In this case, we have x equals to, we have got x equals to 2 to the exponent y. So the examiners, most of the time, they will say we want the inverse in the form y equals to. Yes, here they are doing it. They are saying in the form y equals to, meaning that we need to make y the subject of the formula. How do you make y the subject of the formula? On this equation, I want you to identify the base. You look for the base. 2 is your base. And y is your exponent. So what you do, you come to your base. You come to this base 2. You put log in front of your base 2. Then you just swap those two other guys. You say y stay here, x stay here. So this is the equation of the inverse of g, even though I will write it in this form. So this is the equation of the inverse of g. That was question 4. That was question 4. Interesting. So I'm hoping you are getting the bigger picture of what's happening here. Question 4 of this is question 4 of is November 2023, if I'm not mistaken. It's question 4, yes, November 2023, paper 1. So let's go and look at other question. Now we are going to question 5 of November 2023, paper 1. So the first question says, write down the coordinates of the turning point of F. The key word here is write down the coordinates of the turning point of F. So if we read the information, it's very important to read your information in the exam, guys. They say the graph of f of x is this. This is the equation of the function f. So the examiner wants you to write down the coordinates of the turning point of f. This is simple maths. Normally the first question should be simple, guys. Your turning point here is this guy here. This one is the x turning point, and this y here is the y turning point. The way they wrote your function, it's easy to find the turning point. So you just go to the brackets. Just say in your brackets you have x minus 1. So go to your brackets, x minus 1 equate to 0 and solve for x. Therefore x equals to 1. So this x being 1 is the x turning point of the function f. What is the y turning point? Y turning point, it's easy to spot. Is this number here? Maybe I've written too much there. Let me erase. This guy at the end, the number at the end here is your y turning point. So the y turning point, it's 8. But don't write it like this. Don't say x equals to 1, y equals to 8. We want you to write down the coordinates. So you do this. You say 1 and 8. These are the coordinates of the turning point of f. These are the coordinates of the turning point of f. It was very simple question. Actually, guys, we are looking at the quadratic function which is in this form. F of x equals to a x minus p squared plus q. Most of the time, we can give you the quadratic functions in this form. So when the quadratic function is written in this form, f of x equals to a x minus p squared plus q, it should be easy to find the turning point of this kind of functions. So if I, for example, if I say h of x equals to minus 3 x plus 4 squared minus 6, and I ask you to write down the coordinates of the turning point, it should be easy. You come to the brackets. What you do to the brackets, you equate your brackets to 0. So therefore the x turning point, it's minus 4. It's equals to minus 4. And what is the y turning point? I said this number at the end of your equation, it's your y turning point. Y equals to negative 6. So the coordinates of the turning point of h of x was going to be minus 4 and minus 6. So it's easy to write down the coordinates of the turning point if your function is given in this form. F of x equals to a x minus p squared plus q. Yes, so it was easy to write down the coordinates of the turning point, which is 1 and 8. Now, they say calculate the coordinates of C. You see, guys, this kind of questions keeps coming. The coordinates of C is the y-intercept. This is the most important thing you have to identify. C is the y-intercept because it's whereby the graph of f is cutting the y-axis at C. The graph of f is cutting this line at C. If I give you, look what I'm writing here. If I give you a graph and say this is the graph, it's ugly. Let me write down here. If I do this and say this point is A, this point A is called the y-intercept because it's where the graph cuts the y-axis. This is the y, this is the x. So A is the y-intercept. So in this case, if we go back to our question paper, this C is the y-intercept. They want us to calculate the coordinates of C, where we see that C is the y-intercept because your graph is cutting the y-axis. So how do you find the y-intercept? Remember, you let your x to be 0. So you're going to go to your function f of x. You go and let your x be 0. So you are finding the y-intercept of f. Minus half, you press your calculator here, guys. You just press your calculator. Minus 1 squared is 1, minus half. Minus half plus 8. Minus half plus 8 is 15 over 2. You guys, you will use your calculator. So the coordinates of C is 0 and 15 over 2. These are the coordinates of C. You just put, where there is x, you just put 0 because you are looking for the coordinates. You are looking for the y-intercepts. Those are the coordinates of the y-intercept. C is your y-intercept. That is an easy marks, two marks. No need to put the equation back in the standard form. You just go to x, you put 0. Calculate the value of g. So now we go to this function. G of x equals to d over x. They want to know the value of t. You have this kind of equation. We are now answering 5.3. You are now answering 5.3. You want to know the value of t. You have g of x equals to d over x. So you want to know the value of t. Let's do it. You know that g of x equals to d over x, and you want to know what is this value of t. What you can do, remember g is the hyperbola function, is this function here. It's your g. Even this one is still your function g. So what you do, you can substitute. I'm going to tick what I want you to substitute. You can substitute your x. This color is not that visible. You can substitute your x and this y with any point on your graph of g. Remember, we have the coordinates of b. We said the coordinates of b is 1 and 8. So you go to the function g, where there is y, you put 8. Where there is x, you put 1. Because this point 1 and 8, they lie on the function g. They lie on both graphs. They lie on the function of f, and they are also found on g. Actually, it's the point of intersection. So this point b lies on the graph g and also on f. So you substitute your y and your x by any point found on the graph of g. So d is going to be 8. Write down the range of g. Okay, the range of g. In this case, we are looking for the range of a hyperbola function. Range of g of x. Remember, we found g of x. We say the question was saying g of x is d over x, but we found that d, it's 8, so we are having 8 over x. They want us to write down the range of g, which is the hyperbola. Writing the range of hyperbola, it's simple. You just say y is the element of real numbers. Y, it's all real numbers. Any real number, you say y is the element of real numbers, meaning actually there are many values of y that lies on the function g. What you have to exclude here is the asymptote of y. Y can be any real number, but y cannot be 0. The asymptote of your function g is the y asymptote, it's 0. Okay, let me do it like this. Let's say g of x was this kind of a function. Let's say it was 8 over x minus 2. What is the y asymptote? This number here at the end of your function g. This number at the end, this negative 2, it's your y asymptote. So the equation of the asymptote of y, it's y equals to negative 2. So when you write down the range of the hyperbola, you just say y is all real numbers. The only thing that you need to exclude is the asymptote of y. Y is negative 2. Okay, let me do this one. So the range of this function that we are looking at was going to be y is the element of real number, y is not 0. Y is the element of all real numbers, y is not 0. The one that we are dealing with on the question paper, on question number 5. So if we had something like this, let me say, suppose we have something like this. We have a function of this form. G of x equals to 8 over x minus 1 plus 3. What you need, you guys, you should be able to find the range and the domain of a hyperbola function. And it's actually simple to find the range and the domain of a hyperbola function. The range, you just say y is the element of all real numbers. Y can be all real numbers. But you know that y should not be that asymptote of y. The asymptote of y of this function g, it's free. So you say y should not be free. That is the domain of this function. I mean, that is the range. Sorry, that is the range of this function. Y can be all real numbers, but Y should not be free. But when we talk about the domain, we say X can be all real numbers, but X, in this case, you ask yourself, what is the X asymptote? The X asymptote is 1. So you say X can be all real numbers, X should not be 1. Actually, guys, concerning hyperbola, you need to be very, very, very careful. That's why I'm saying, I know I'm answering this question of question 5, but I'm also looking at other possibilities, other possible questions. So let's say you had g of x equals to 8 over x minus 1. Let me say minus 2. This is the equation of hyperbola. You should be able to find the domain of an hyperbola function. How do we find the domain of a hyperbola? Simple. You say x is all real numbers, but x should not be. Ask yourself, what is the x asymptote of this function g? To find the asymptote of an hyperbola function, the x asymptote, you just go to your denominator. In this case, your denominator is x minus 1. You go to your denominator, you equate your denominator to 0. So this means that the x asymptote of your function g, it's 1. The x asymptote is 1. So when we give the domain, we say x can be all real numbers, but x cannot be the x asymptote of the function. So the same with a range. Okay, before you find the range, you can ask yourself, what is the y asymptote of this function g? This number here at the end, it's always your y asymptote of g. Is your y asymptote of g. So the range is going to be y, it's all real numbers, but y cannot be negative 2. So you get how to write, hopefully you understand how we write the range and how we write the domain. Another thing that they can ask you in the exam is the axis of symmetry of a hyperbola function. Make sure that you know how to find the axis of symmetry of a hyperbola function. Let me just touch on that as well. What if they say, what is the axis of symmetry of this g of x, this one here that I've wrote here, g of x 8 over x minus 1 plus 3? You have to know that we have got two axes of symmetry. Hyperbola has got two axes of symmetry, the one with a positive gradient. Let me start with the one with a positive gradient. The axis of symmetry with a positive gradient, which is also called the increasing function. That axis of symmetry, which has a positive gradient, is the increasing function. So it's easy to find it. You just come to an equation, you do this. You pick this part. So the axis of symmetry is y equals to x minus 1. You see where x minus 1 comes from? You add this 3. Therefore, the axis of symmetry of a hyperbola is y equals to x plus 2. But what if they say find the axis of symmetry with a negative gradient? You can do the same. You say y equals to, you go to your denominator. In this case, your denominator on this function was x minus 1. That denominator, multiply it with negative. So you say negative x minus 1 plus 3. So y equals to negative x plus 1 plus 3. Therefore, y equals to negative x plus 4. This is the equation of axis of symmetry with a negative gradient. This one is the equation of axis of symmetry. This one with a positive gradient. I was just reminding you how to find the axis of symmetry of a hyperbola function. So here they want to know for which value of x will f of x, we are on 5.5, for f of x times g of x be less than or equals to 0. Okay, the only time you will get the answer below 0 is when you multiply negative with positive or positive with negative. So how you approach this question, guys, I want you to find uh, the x values whereby f is underneath the x-axis and g is above the x-axis. If you look when let's come to this diagram. When x is negative 3, go to the point where x is negative 3. All values of x on the left of negative 3, for all values of x on the left of negative 3, you realize that your function f, which is here, it's underneath. But where is the function g? The function g also, it's underneath. They are both underneath when x is on the left, and for any value of x which is below negative 3, both functions are below the x-axis. So let us look when x is above this side from negative 3, actually where, okay, at this point when x is 5. Let us look when x is 5. Let us focus where x is 5. If you look at the values of the right, if you go to the right, for all values of x which are now above 5, your function f is underneath. Actually, let me do this. I know these are very tricky questions. Let me do this. I want to explain this one more better. I want to try to explain it better. This is the where x is 5. I want us to go to the right of this x being 5. Yes, this side. So we realize that at any point on the right of x being 5, your function f, when you look at the function f, it's down there, but the function g, it's on top. So when x is above 5, I want you guys to look that on your graph. When x is above 5, at any value of x which is above 5, at any value of x above 5, whether being 6, 7, 5,1, 8, whatever, from this point, at any value of x above 5, at any value of x on the right side of 5, your function f is always underneath your x-axis. Remember, your x-axis is this line. So your function f is always underneath, but your function g is always on top. So this means that whenever we take, let's say that when the function is underneath, it has got a negative y value. When the function is underneath the x-axis, let's say it has a negative value. And when the function g is on top, let's say it has a positive value. So we realize that when x is above or equals to 5, the two functions, when we multiply them, they will give us the value which is 0 or it's below 0. So the correct answer here is when x is above 5. When x is equals to or above 5, the two functions, when we multiply them, they give us 0 or they give us a value which is below 0. How do I know? When I multiply negative, remember I said when the function is underneath the x-axis is negative. So when I multiply negative with positive, I get the negative answer. So the correct answer here is x is greater than or equals to 5. So calculate the values of k so that the h of x being negative 2x plus 4 will not intersect the graph of g. H of x, they want to know the values of k whereby the function h will not intersect with the function g. At which values of k will the two functions not intersect? Which two functions? the function h and the function g. Okay, let me write down the equation of h. The equation of h, they are saying it's negative 2x plus k. What is the equation of g? The equation of g, they are saying is, I think we have the equation of g, or the equation of g, remember, it's 8 over x. Now they are saying at which values of k will the two function not intersect. I want us to equate these two functions. I want us to say 8 over x equals to negative 2x plus k. Normally we do this when we are looking for the point of intersection. We equate the two equations. So, but in this case, we want to know at which value of k will the two function not intersect. Okay, we are having 8 over x equals to negative 2x plus k. Let me try to multiply throughout by x. So I'm going to 8 over x by x. What can I do here? 8 over x by x is going to be 8. Yes, 8. I want to remove the denominator, equals to minus 2x squared plus k of x. I multiplied every term with x. This is kx. Let me call it xk. Let me call it xk. K times x, it's xk. It's also kx, but the way I was going to write it, it was going to be as if it's a function. Let me write it as xk. I multiplied. My goal is to remove this guy underneath. So I multiply 8 over x by x, it's 8. I multiply negative 2x by x, is negative 2x squared. I multiply k by x, you can say it's kx or xk. Let's call it kx. Yes, it's better to call it kx with the assumption that k is just a number. It's just a number, like kx, k representing a number. So if k was, for example, was 2, it was going to be 2x. So I'm writing kx with the idea that k represents a number. So now I see this as a quadratic equation. I can say this is minus 2x squared plus kx minus 8. Actually, this side is 0. I pulled minus 8 to the side. So we are left with 0 on the left side. So it's 0 equals to negative 2x squared plus kx minus 8, which is actually a quadratic equation. So whenever, in this case, I will look for the discriminant first. I will say the discriminant of this quadratic equation, which is b squared minus 4ac. I will explain why I'm looking for the discriminant. The discriminant equals to b, it's your k squared minus 4, a is minus 2, c is minus 8. For sure you know your, here it's a, here it's b, here it's c. For sure you know how the quadratic function looks like. So now my discriminant, I'm erasing here faster, guys. So now my discriminant is k squared minus 4 times minus 2 times minus 8. This is minus 64. K squared minus 60. You'll press your calculator. Minus 4 times minus 2 times minus 8 is minus 64. So your discriminant, it's k squared minus 64. And we know that we don't have a solution for a quadratic function whereby the discriminant is less than 0. A quadratic function which has the discriminant of less than 0, they have got no solution. So I'm saying for me to find the values of k whereby the two functions do not intersect, I will say that will happen when the discriminant is less than 0. When the discriminant is less than 0, there is no solution. It means at that point, the function do not intersect. At that value of k, the function do not intersect. So k squared minus 64 being 0, being less than 0. Then you say k squared being less than 64, which is the same as I'm writing here. K squared is less than 8 squared. It means that k is less than 8. See that your exponents are the same. So when k is less than 8, the two functions will not intersect. At any values whereby k is less than 8, the two equations will not intersect. The two functions will not intersect. So now I want to go to 5.7. I want to go to 5.7. I'm erasing faster. We do 5.7. What do they want at 5.7? If, okay, they are saying h is tangent to g. I normally prefer to create diagram. So let me say this is your function g. And they are telling you that h is tangent to g. I will just create a point of tangents. Let me say this is a function g. Suppose it's tangent at this point. If h is tangent to g, I'm saying this is my h and this is my g. I'm trying to visualize what's happening. Visualization is very important. So I'm saying they're saying h is tangent to g. This is the green line represent function h, whereby is tangent to the function g. H is tangent to g at r. Okay, so I will use what's happening. Okay, at r, so I will say at this point, at this dot here, they are saying it's r. H is tangent to g at r. A point in the first quadrant. They are saying this is happening in the first quadrant. A point in the first quadrant. Calculate t. The problem wants us to find t. Calculate t such that y equals to f of x plus t. Okay, y such that y equals to f of x plus t intersect g at r. F of x plus t, y equals to f of x plus t intersect g. So they're saying this function here, this equation here, y equals to f of x plus t is intersecting g at r. Okay, okay, so calculate t is intersecting g at r. If h is tangent to g, I've drawn it on the diagram with a green arrow. If h is tangent to g at r, a point in the first quadrant, calculate t such that y equals to f of x plus t intersect g. Guys, it's very important to note that they are saying this y equals to f of x plus t is intersecting g at the same point r. So you can y equals to, we will reach a point whereby they're saying y equals to f of x plus t intersect g. Okay, let me write these two functions. Y equals to f of x plus t, and the function g is what? It's 8 over x. So they are saying these two functions, they intersect at r. And we know that if the two functions intersect, we can equate, if the two functions intersect, you can equate this part of a function, f of x plus t, with this part of a function, 8 over x. So you can say f of x, but we know what is f of x, right? F of x is minus a half x minus 1 squared plus 8 plus t, I'm equating it to 8 over x. Guys, hopefully you are paying attention here. This f of x plus t, remember this part here up until 8, this is your f of x. If you look at the question paper, they told you f of x is minus half x minus 1 squared plus 8. So this portion here represent f of x. So they're saying y it's f of x plus t. So that's why I said f of x plus t. And they're saying this equation y equals to f of x plus t, it's intersecting with g of x. So I'm saying we will need to equate these two functions, which is, this is the function of f of x plus t, this is the function of g. But when we equate them, immediately after equating them, we see that we have got two problems. We have got two variables. We have got x and t. In our equation, we have got two variables. We wish to know actually at which point does the two function intersect. We are told that they are intersecting at the point r. We wish to know the coordinates of r. How can we know the coordinates of r? How can we know the coordinates of r? It's a bit tricky. Wow. It's a bit tricky because to find the coordinates of r, which is the point of tangent of what? If h is tangent, you see now, h is tangent, h, they are referring to this function h on 5.6. That's why this question is getting complex to me. They are referring to h on 5.6, whereby the gradient of h on 5.6 is minus 2x. So what I will say to you, I will say, remember, h is tangent. At the point of tangent, h is tangent to g. At the point of tangency, g and h have the same gradient. So I'm going to derive g. I'm going to say g of x. Remember, g of x was 8 over x, which is 8 over x is the same as 8 x to the exponent negative 1. Remember, in order for us to derive, we need to bring the x as the denominator on top. You cannot derive, if x is underneath, you cannot derive the function. You somehow need to bring x on top. So this is 8x to the exponent negative 1, and the derivative of g is minus 8x to the exponent negative 2, which is somehow, this minus 8x to the exponent 2 represent the gradient at any point. And we know that when h and g intersect, they have the same gradient. Actually, we can tell from h that the gradient is negative 2. So you say g prime x, you equate it to negative 2. This is a very tricky question. Then you start solving for x. This is the same. I can divide both sides by, is it a quad? This is the same as minus 2 equals to minus 8 over x squared, which is minus 2x squared equals to minus 8. Then you can bring minus 8 to the other side. So it's going to be minus 2x squared plus 8 equals to 0. Or how can we solve for x here? Minus 2x squared equals to minus 8. Guys, let me write here. Minus 2x squared equals to minus 8. You can divide both sides by minus 2. So you're going to have x squared equals to 4. So you put the square root both sides. X equals to plus or minus 2. X equals to plus or minus 2. So we have got two possible values of x. At the point r, I see two possible values of x. X can be 2 or, but they set in the first quadrant. Thank God. In the first quadrant, it means at the point of intersection, x has to be positive. In the first quadrant, x is positive. So we leave x cannot be negative 2 because we are in the first quadrant where x has to be positive. So this function, they intersect where x is 2. It means that I will go now and say minus half 2 minus 1 squared plus 8 plus t equals to 8 over 2. Remember x is 2. Then you start solving for t. 2 minus 1, it's 1. 1 squared, it's 1. Minus a half plus 8. You press that one on a calculator. Minus half plus 8. I think it's 15 over 2. This is 15 over 2 plus t equals to 8 over 2. You make t the subject of the formula. T equals to 8 over 2 minus 15 over 2. T equals to minus 7 over 2. So it's t is minus 3,5. It was a very tricky question, this one, guys. It was a very tricky question. And when I was answering 5.7, I overlooked that I can use the information of 5.6. Remember, on 5.6, it's where I have the equation h. And I know the gradient of h is negative 2. That gradient of negative 2 is very, very, very important. Guys, I will continue with other questions of November 2023. I just have to stop here. Hopefully, you are learning something from these two questions, question 4 and question 5 functions. All the best. Good luck with your maths.